In this video, I'm going to talk to you about FLAMES naming conventions that should be used in software development. Naming conventions are important for a number of reasons. One is that it allows the software that you write, or prevents the software that you write, in particular the global names that you define in your software, such as class names, from conflicting with the names in FLAMES or the names that are used and developed by other software developers. Because there's a wide community of FLAMES developers and everybody's all doing their own development, we got to make sure that people don't end up choosing the same name. Another reason that naming conventions are important is that it really helps the software to be more understandable and more readable. If you're naming files and naming functions and classes in a consistent way and you're familiar with the conventions that are used, it's much easier to understand software that you're looking at. One of the biggest reasons for our naming conventions is to allow the software that we write to be compatible with the FLAMES Component Copier. And we'll talk about that in another training video, how to copy FLAMES components. So with that, let me just dive right into the conventions. First of all, there are, I'm going over the information in the developer's manual and the FLAMES development guide in the section in here on naming conventions. So the first thing I'm going to talk about is organization prefixes. So an organization prefix is just a 4-character prefix that is reserved for your FLAMES account, and maybe one that is shared among all the people in your organization. That organization prefix should be used in the definition of all your global names and in all of your files. And that will make sure that your global names never conflict with FLAMES functions, FLAMES global names, as well as the names of other organizations. You can assign or reserve an organizational prefix from within the launcher. So let me show you where that can be done. So in the launcher, go to your account icon here and click on Settings. This particular settings page explains organization prefix, the stuff that I'm talking about right now, and you just type in the prefix that you want and you can reserve it. The prefixes, as it explains here, they can't start with F, J, or T because Turnitin uses those first letters in its names of global variables and functions. And also it can't start with a number. It has to start with a character, but it can have numbers in it after that first character. And while you define the prefix as all caps, when you're defining characters, the prefix can be used upper or lowercase. So when you actually use it in your code, it's case insensitive. So again, you go into the launcher, you define that prefix, and then you'll use it in naming, and we'll talk about where that's done later on in this video. You'll also get a integer ID that's your organization ID, and that is used when you're defining FLAMES records, and we'll talk about that in another video as well. So organization prefix, so now let's go on and talk about places where the organization prefix gets used. So first we have general naming conventions. So all the global names should begin with your organization prefix. And what we suggest is that you use camel case with the first letter being capital. So camel case can be either first letter capital or not capital. So we say first letter capital. So these are examples of global names with an organization prefix of ABCD. And you'll notice that when you look at the code, all of the FLAMES functions will begin with F, J, or T. Now, when you define preprocessor or precompiler macros, our convention is to have those always be all uppercase. So it's easier to recognize macros when they're used in the code. So that's not always the case. When we have macros that really are intended to look like functions, those will look just like normal function names, but most preprocessor macros are all uppercase. And again, the ones that you define should begin with your organization prefix. If they're global, if it's just local in your own files, you can name them whatever you want. The data types enumerated data type constant values, we usually name those as all uppercase. So in Flames code, source code that you get out of the Flames repositories, you'll see that we follow that convention. Just makes the code a little bit easier to read. Generally, the convention for naming functions should conform to the pattern of noun, verb, and then optionally object of the verb. So here's the name of a function. So this would be the class name, ABC sensor. The verb would be detect. So starts with a noun, then there's a verb, and then if you need to be more specific, you'd have the object of the verb. So here's a detect platform. We follow that convention very closely in all the functions that we've defined for Flames. So you can just look at the function and figure out what class is it a part of, and then what does the function actually do just by looking at the name. Now, of course, if this was a C++ member function, there'd be colons after the class, double colons. So this is maybe a little bit unusual naming convention for member variables, member names inside of a class. It's our convention that we name the member variables always with the leading capital letter, and then we're using camel case. That's real important. And by the way, I need to mention that these naming conventions are important also for another reason. If you submit code to the Flames repository to be included, like put in a pull request and want to make changes or add new classes to our repositories, your code's going to have to follow these naming conventions. So we always name member variables with leading caps. But then in C++ code, if it's a local variable in a function, we will always name that local variable with a lowercase leading letter. The reason for that is it gets over one of the side effects of a really nice feature of C++. C++ allows you to reference member variables when you're in a method of member function that belongs to a certain class without having to put a reference to the class object in front of it. And that's really nice. That's one of the nice features of C++. But when you're looking down through the code, it's not obvious unless you have a naming convention when you're referencing a member variable of the class or when you're just referencing a local variable. So our convention is to always make the local variables lowercase, and it just makes the code a whole lot more readable. Of course, in C, you don't need to do that. So a lot of code written in C, you won't find that. Now, as you already know, almost all of the code that's in the Flames repository is written in C++ because we recommend C++ as the programming language for doing Flame software development. So you won't see much of this. But next convention is how we name data types. Data types conform to that general naming convention that I just talked about, but there's a couple extra things that I want to point out. So here's a class. We talked about it. It has a prefix and a noun. A C class, this is something that you'll need to know, even though if you're writing models for Flames yourself, components for Flames that are written in C++, you'll never define data types like this yourself. But because Flames classes are in C, you will see this convention. And this, I want to tell you about this so that when you see it, you'll understand it and it'll help make the code more readable. In C, if you define a class, you've got this other keyword here, and so it's obvious that this is a class. In C++, you don't really have anything that's a class. It's just a data structure. And if you know anything about C++, you know that struct and class are synonymous in most cases in C++. But in C, a class is just a data structure defined with a struct. So you really don't know when you look at a definition of a struct whether it really is just some general purpose struct or whether it is intended to be a struct that is the definition of a class. So in Flames, if we have a struct that's the definition of a class, we'll put this little def at the end of it. So you'll see that in Flames include files, you'll see defs, and that means that they are a class definition structure, not just some other type of data type. Similarly, for Flames data types, so if we have this data types that have an obj as a suffix. This means that this is a pointer to an instance of a class. So this is the actual class definition structure, and this is a pointer to it. So you'll see obj data types in Flames all over the place. So that's really common. So now you'll know what it is when you look at it. There's another type of data type. This is a real subtle thing. It's the PTR data type. And this is used, you'll probably never have an occasion to define a type like this yourself, but unless you're writing classes in C, this is used by FLAMES functions, which are all written in C, for declaring the first argument to functions. So this is a little subtle thing. It's talked about in more detail here. You can read about it. I'll just tell you briefly. C++ is much more strongly typed, which is an advantage of C++. But C is also pretty strongly typed. But C++, when you're calling a function that is intended to be a function of an abstract class, and you pass in a subclass as the first argument, C++ knows the whole class hierarchy, and it will let you pass in a child class object into the function. For example, if you have a sensor model, you can call an fEntity function, and C++ knows that sensors are subclasses of fEntity. So when you pass in a sensor to an fEntity function, C++ is fine with it. C would not be fine with it because C is not smart enough to know about the class hierarchy. So if you passed a sensor pointer into an fEntity function in code written in C, the compiler would say you're passing in the wrong type. We have these data types that we use just for declaring those first arguments to class functions. And we define them differently in C and in C++. So in C++, it's defined to be the actual class object pointer. But in C, we define it to be a void star. And that allows us to call it with say, for example, pass a sensor into an fEntity function and not have to do an explicit typecast of that sensor object. Just eliminates a lot of extra typing for typecasting. It makes the code a little bit less strict because it's not kind of blows away the strict typecasting. But since we recommend that you write all of your code in C++, and all of our models that we have in the repository are all in C++, you'll get to take advantage of the stronger C++ typecasting. If we define a data type, a structure that is intended to be used to define a FLAMES record, and you're going to learn about that in another training video, the data structure type def will always have record at the end of it. So if you go look at a type and you see its record, you know that was used to define a FLAMES record. If it's just a general purpose type, we will use type as a suffix. So it'll help it distinguish it from being a class or an object pointer or a record. We know it's a type. So those are some conventions that you'll see in the include files and function calls, formal declaration of functions in the FLAMES source code. So now on to file naming conventions. We use a all lowercase version of the class abbreviation in naming files. Now, you don't have to do it this way, but this is how we do it. The suffix stuff, though, is important to follow. So for example, let's say that we have a C++ class and the organization prefix for our organization is ABCD. So the class name would be a noun, so say ABCD sensor. Well, the class abbreviation would be the same. This is not the organization prefix, but it's the class abbreviation. We would pick an abbreviation that is the same organization prefix followed by a couple characters, an abbreviated representation of the full class name. Class abbreviation should be something different from the full class name. I think we have a couple of models in the FLAMES repository where we don't follow that convention, and I think we're going to fix that in future versions, but in most cases it needs to be different, and that's because of the component copier. When it's doing its copying of a component, it needs to be able to tell the difference between the class abbreviation and the full class name. So we use that class abbreviation in the naming of files. So the include file would be named .h, as is standard for C++ include files. The main class file of the class is always the class abbreviation, just by itself. And that's universal throughout all of the classes that you'll get out of the FLAMES repository. And that's how we say you need to name your files. And that is an important convention. Then for other files in the class, there'll be a short suffix after it that'll indicate what types of files are in, what types of functions are in that file. So for example, user interface functions that are used for the user interface of the class in Forge, for example, would have UI at the end of it. ATTR is attribute files, IO is IO files, exec is exec files. You'll get into that more when we talk about building specific classes. So this is just the convention. starts out with the class abbreviation and then some kind of a suffix. C class files, again, you're probably not going to be writing models in C, but we want to tell you what our convention is because you're going to see this in the include files that come with Flames. Same convention, we have the class, the organization prefix, the class, and then here is the class abbreviation. For C classes, we break the include file, which is normally just a .h file in C++, we break it into two pieces. We have a PRV file, which stands for private, and an SPC file, which stands for specification. The PRV file is included only in the files that implement the class. The SPC file is included in those files and also in any class that uses that class. So it's the external specification, the external interface for the class. We tell you about this just because you're going to see that in Flames include files. Most of the Flames include files are SPC files. And the reason we break it up this way is this is an ironclad way of enforcing encapsulation that is enforced by the compiler, because normally C doesn't have any way of enforcing encapsulation. You can't declare a class and put private sections because private keyword isn't recognized in a C structure. But this way, we put the actual class definition, the .def, in the PRV file, and then the external part of it is in the SPC file. So you'll see both PRV files and SPC files in the Flames include files. Most of them are going to be SPC files because we're not revealing the implementation, the internal implementation of the class. But the classes that you're going to inherit, like fEntity and fEquipment, those classes you have to have the full class definition. So there'll be PRV files for those classes in the Flames include file. So now you know what they are when you see them. And then we have the same convention for naming the source code files. So the last naming convention that I want to talk about in this video is the include file macros. And this is pretty simple. For most Flames include files, we define a precompiler preprocessor macro that we use to refer to the file. So when you're, with the exception of some top level parent include files like fEquipment or fCognition or flames.h, all the other include files, you will not include those files directly. So if you go into the include file in the source directory and you see a bunch of files in there, most of the time you shouldn't include those files by looking at the name that's in there. Instead, you should use an include file macro. The macro is always the full name of the class. So if you are going to call an funit manager function, you would include the funit manager _use. And the use macros would include the SPC file. The inherit macro would include the PRV file if the class is in C++. If it's in C, use and inherit include the same file. But you don't have to know the difference. If you're going to just use unit manager, you would include it by referring to this macro. So the macro does a couple of things for us. First of all, as I've already explained, we name the include files for classes using the class abbreviation. So the full class is never used to name the include files. So if you want to include an include file for a given class, and we've got many dozen classes in Flames, in the Flames kernel that you'd be using in the development of your models, you'd have to go look up what the class abbreviation is for the class. We don't even remember that ourselves at Turnian. We don't have to remember it because we get to use this include file macro, which is always the full name of the class. So if you call an fsensor function, you would include fsensor use. If you're going to call the kernel mem allocator, you include fkernel mem use. Just whatever the name of the class is, that's going to be the name of the macro. And again, if you're going to include the PRV file, or you're going to inherit that class, like inherit fsensor or inherit fcognition, you would include fcognition _ inherit, or fcpp cognition if it's the CPP version. The other advantage of the include file macro is if the include file is actually in some kind of a folder, we can move that file to a different folder, and we can actually rename the file to something else, and all the code that you use that includes that file won't have to change. So sometimes we decided to rename files in Flames, and so our internal files are different, and we release a new version of Flames, and a bunch of include files might have different names. That'll be completely transparent to you. You won't have to worry about it because we have these macros that always point to the proper file. So those are the naming conventions. Again, they have a lot of advantages, and we abide by those in the code that we write, so it'll make it easier for you to understand the code that you get out of the Flames repositories. And you need to follow those conventions when you write your code if you ever want to submit any of your code to the Flames repositories. Thank you for watching this video, and thank you for using Flames.